We're going to go over some concept notes for exponential functions. What is an exponential function? Well, it looks like this, where f of x is equal to a to the x power, where a is going to be a number. Now there's a few restrictions on a. A has to be greater than 0, and a cannot be 1. The input can be any real number though. Why can't a be equal to 1? If we had a being equal to 1, then we would have f of x is equal to 1 to the x power, which is always 1. This graph would look like a horizontal line passing through 1. And this is what the graph of that equation would look like. Doesn't have a very curved shape, and it really doesn't help us to figure out what these exponential functions are all about. Something maybe even a little more interesting will happen when a is less than 0. So let's take a look at that second part here. I'll move this up just a bit. So if a is not greater than 0, so if a is negative, like -2, what's going to end up happening is something that's a little weird. So let's take a look at f of, f of 0 is equal to -2 to the 0 power, which is 1. And then f of 1 would be -2 to the first power, which is -2. And if we had f of 2, that would be -2 to the second power, which is 4. So what winds up happening is the outputs, or the y values, just oscillate, and they get larger and larger, or more and more negative. So we would oscillate from 1 to -2, then to 4, then to -8, then to +16, and so the graph of this is not going to form something that's continuous. So we need to have a being greater than 1, and also a can't be 1, or we don't get a graph that looks like either one of the two below. This is the shape of a graph. It happens to be 2 to the x power, but here we're going to say that for this graph, a is greater than 1. And we're also going to call this growth. As x increases, the y values increase. So there's growth in those y values. This situation over here on the right-hand side is a little bit different. I'll move that up just a bit so you can get out of the shadow there. So this shape of the graph looks very similar to this one, except as we continue from left to right, all of these y values are decreasing. This is a situation where a is between 0 and 1, so it could be a third or a quarter or a half or 3/5 or 7/8, something like that. And this is a situation that we're going to call decay because those y values are decreasing.